Multiplying radical expressions is really not that different from simplifying single radical expressions, except for the fact that when you have the product of two individual radicals, they can be rewritten together as the single radical of their products. And similarly, if you have two individual radical expressions, maybe that each have coefficients in the front, again, you multiply what's under the radical sign, we call that the radicands, and put it under one radical symbol, and then you just also multiply whatever the individual coefficients were to get a new coefficient. After multiplying the two individual radical expressions, you always want to remember to simplify. So to show you an example of a problem that might involve using this, consider the square root of 15n squared times the square root of 10n to the third. Again, even though these are simple and single radical expressions, we are going to combine them together to be one, maybe slightly more complicated in the beginning, radical expression that we can simplify. So I'm going to multiply the two numerical parts of the radicands and multiply the two variable parts of the radicands. That would give me the square root of 150, and when I have n to the second power being multiplied by n to the third, if I kind of write that out just to show you, that should combine to make an n to the fifth power in total. Now this is just a problem like we've seen in our simplifying radical expressions notes, and so I'm going to start by breaking down the numerical part of the radicand to say, well, 15 and 10, those are two factors that their product would make 150. I can break 15 down into being 3 and 5. Both of those are prime numbers, so I underline them. 10 gets broken down to be 2 and 5, which again are prime numbers, so I underline them. And so underneath my larger radical, I now have the numerical factors of 2, 3, 5, and 5. In addition to that, from the variable portion of this, n to the power of 5 means I have 1, 2, 3, 4, 5 factors of n. And now I'm going to highlight the pairs of factors that I have in common. In this case, I'm going to highlight a pair of 5s, one pair of n's, and a second pair of n's. And again, if I highlight a pair of factors inside the square root, when they come out, that would be 1 5 from this pair, an n from this pair, and another n from that second pair. And that's all that we got to take out of the radical. And what's left behind is 2 times 3 times n. To get my final simplified answer here, I'm going to try to simplify the way that I have the outside part written here. Instead of 5 times n, I can write this as 5 n to the second power times the square root of, instead of 2 times 3 times n, I say 6n. And this would be my simplified answer for the original multiplication problem that we were given up here. Another example, slightly more complicated. If the original problem is -3 times the square root of 7r to the third times 6 square root of 7r to the second. Again, it's individual radical expressions, but since they are being multiplied, we can combine them to be one radical expression to simplify. I simply multiply the two coefficients, so in this case, -3 times 6, and then underneath the radical, I multiply the two radicands. So I get 7 times 7 times r to the third times r to the second. So the one simplified radical expression we're working with here would be -18 times the square root of 49 r to the 5th. Now don't forget to break down what's inside of the radical if at all possible, meaning in this case that 49 can be broken down as 7 times 7, both of which are prime numbers. And I also can rewrite these r to the 5th. This part here, I can rewrite that as r times r times r times r times r 5 times. Now, you may not have actually needed to do this step right here. It's possible that back at this step, you saw a pair of 7s and knew you could take them out. You also might be able to look at r to the 3rd and r to the 2nd, knowing that those would multiply to make r to the 5th. And you can think to yourself, well, out of 5 individual r's, that would create 2 equal groups of 2. And so I'm going to pull 2 factors of r out. And there would be 1 factor of r that would get left behind. So it's not necessary for you to do all of this, but especially in the beginning when you're still kind of getting used to how these problems work, I always encourage you to write out as much as you need to, because if it helps you to visually see the pairs of 7s here and the 2 pairs of r's here, there's nothing wrong with writing it out. Because either way, you should hopefully wind up at the same answer, which in this case, like I said, take out a pair of 7s here would become 1 factor of 7 on the outside. I've got a pair of r's that I can take 1 r from, another pair of r's I can take an r from, and then the only thing that gets left behind under the radical is 1 lonely factor of r. Putting these two together, negative 18 times 7. If you don't have a calculator handy, don't forget that you can always do math by hand. There's nothing wrong with that. And so I would get a final answer of negative times a positive makes negative 126 r to the 2nd power times the square root of r. And that would be the final answer for this product. One more example I want to show you is probably one of the more complicated ones you could expect to have, but I'm going to break it down for you step by step so that you're able to answer a problem even that looked like this. Notice here that there are parentheses, and so you might be thinking order of operations and, oh, I can put together the things inside parentheses first, but you should notice here that I hope that gives you hesitation. I don't know of a way to combine the square root of 6 plus 2. So since I can't put these things together in the parentheses, I need to go a little bit farther and say, well, this right here, the 2 root 5, it's outside of the parentheses, which means it should be being multiplied by what's inside. You may recall, like if I give you a simpler example here, back in your middle school or 9th grade, previous year's math courses, if you saw something like this, hopefully you would really easily know to distribute or to multiply the 2 times 3x to make 6x and the 2 times the minus 1 to make minus 2. This is essentially what we are going to be doing with this example. We're going to distribute or multiply the 2 root 5 first by the square root of 6, and then we're also going to multiply the 2 root 5 by 2. And so if I write that out, I'm multiplying 2 root 5 times the square root of 6. And I'm also going to multiply 2 root 5 times 2. And since these are both positive, that would mean that this addition sign would still say plus. And again, 2 root 5 is multiplied by this 2. And so what we have now essentially is kind of 2 little baby multiplication problems that we can work individually at first. And so remember, if you're multiplying 2 radical expressions, you multiply what's outside by what's outside, which in this case, even though there's nothing written, you can kind of think of it as the invisible 1. So it'd be 2 times 1, which is 2, and then multiply what's under the radicals to combine it to be 1. So the square root would now be of 5 times 6, which is 30. Then over here, with the second problem, this 2 is outside, and really it's kind of like this 2 is outside. You could almost imagine kind of like a little imaginary square root of 1 here if you need a radical. And so the 2 gets multiplied by 2 here to make 4. And this would be the square root of 5 times the square root of 1, which would be just still the square root of 5. Now at this point, I could be done with the problem and this could be my final answer, but before I can say that for sure, I need to look at these individual radicals to see if they can be simplified any further. I think 5 is pretty obviously already simplified, and so 4 root 5 is already a simplified version. Over here, you might be tempted to say that the square root of 30 can be simplified, because you might say, oh, well, I know 30 would break down to be, I don't know, 3 times 10, and then that 3 would be prime, and 10 is going to break down, say, to be 5 and 2, where 5 and 2 are both prime. But then if you tried to write this under one single radical, do you notice that there are no pairs? So nothing would get to come out. And essentially, you would wind up putting them back together to say, oh, it's still just the square root of 30. So in this case, 2 times the square root of 30 is also in simplified form. So I don't have to go any further with either of these, which makes the final answer to this problem 2 square root 30 plus 4 square root 5. And that is 3 examples of multiplying radical expressions to kind of go along with what we started first with simplifying.